Okay, so we're moving on to example 5, and in order to do example 5, we need to know a little bit more about verifying identities when we have to work from both sides. So this is where these get just a little bit more complicated. So if the identity, really, I can't spell. Actually, the problem is I can't type. If the identity appears equally as difficult on both sides, you can work from each side toward a common third expression. So we're going to start, it actually really doesn't matter where you start. You can start on one side and you're going to work until you get it simplified, and then you're going to start from the other side and work until you simplify to the same third expression. Now, I'm going to be honest, these can be a little bit difficult because you kind of have to figure out where you're headed, and sometimes that can be a little bit tough. One of the things that you have to remember with problems like this is that they have to be, each step has to be reversible because you're going from one side to a third expression. So for example, if this is the left, I've got the left side of the expression and the right side. I'm going to work the left side all the way to this third expression. And I'm also going to work the right side to this third expression. But I would have to also, and the good news is you don't have to do this, but you would also have to be able to go from the third expression all the way to the right side and back to the left. So everything has to be reversible. So you'll see on this first example, and like I said, these are a little challenging because sometimes you really don't know where to start or where you're headed. So you're still going to follow the same rules. Now, obviously, we said that both sides seem equally as complicated. So it's the other part of the rules that you're going to follow. So in this case, if I look at this, I notice that this is squared and this is not. This has a sign, this does, but this doesn't. This is a trinomial that can be factored. And so that's where I'm going to start. So this time I'm going to start on the right side. Now, I could start on the left, but to me, this jumps out as being something that needs to be done. And so I'm hoping that when I simplify this side, I'll figure out where I'm headed, and that'll help me to determine what I need to do on the other side. So I'm going to go ahead and factor this. It would factor as 1 plus sine alpha squared, or 1 plus sine alpha times 1 plus sine alpha. Now, if you're not sure where I'm getting that, pretend that the sign is just a variable. So pretend it looks like this: 1 plus x squared. I'm sorry, 1 plus 2x plus x squared. Or if you wanted to turn it around, x squared plus 2x plus 1. I could factor that easily. And that's exactly what this is. It's just that instead of an x, you have sine alpha as your variable, so to speak. All right, so I factored that top piece. And let me get my pen back. And at this point, I'm not going to do anything to the bottom yet. All right, so I'm still working on the right-hand side. I'm going to go ahead and write this as 1 plus sine alpha and 1 plus sine alpha, because I can change cosine squared alpha to 1 minus sine squared alpha using my Pythagorean identity. And this factors, so I'm going to keep going over here on the right-hand side, as 1 plus, this is the top. I didn't do anything to this time. And the bottom factors as 1 plus sine alpha and 1 minus sine alpha, because it's a difference of 2 perfect squares. And that's something that you're going to have to recognize. You're going to do it probably several times in these activities. Now, I see that I have one of these that can cancel and one of these that can cancel. Wow, that keeps erasing that. There it goes. Okay. And that leaves me as 1 plus sine alpha over 1 minus sine alpha. Now, what one of our instructions for verifying identities said was try to get everything in terms of sines and cosines. So at this point, I don't have anything that's squared anymore. I don't have any arithmetic that needs to be done, and I'm in terms of complete signs. There's nothing that'll cancel. So I'm going to assume that that is my simplified version, and that is where I'm going to try to work my left side to match. I'm going to try to work from the left and end up here. So the first thing I'm going to do is, let me think for just a second. Okay, I think I'm going to multiply both the top and the bottom by cosine alpha. I'm going to try to get myself to a Pythagorean identity so that then I can factor and get down to here. So that's going to give me cosine alpha secant alpha plus cosine alpha tangent alpha. And that gives me cosine alpha secant alpha minus cosine alpha tangent alpha. So 1 plus 1 minus. All right, so now don't forget that tangent is sine over cosine, which means that I'll go ahead and write it out. And that's another thing about trig identities is every now and then you could skip a step, but don't skip too many because that's the point, is proving something. And like technically you really could skip this one, but I want to make sure everybody knows what I'm doing. So okay, so I'm just rewriting tangent as sine over cosine. Well, now cosine will cancel. So and I probably could have done this all in one step and leave me just sine. And secant is the same as 1 thing over, it's the same thing as 1 over cosine, which means I have cosine alpha times 1 over cosine alpha minus, sorry, this one's plus, sine alpha over cosine alpha 1 over cosine alpha minus sine alpha. And these become 1, which means I have made it to where these two match. So that's all for that one.